Okay, we're going to have a go at differentiating this problem because we need to find the second differential. So let's do that. Differentiate this. We're going to times by the power, so we get 3x squared. And then take 1 off the power, that's where the x squared came from. Plus, times by the power, well the power effectively is 1. So we're going to times by the power, so we get 2. Take 1 off the power, leaves you x to the naught, which is just 1, so it just leaves us 2. And you should know by now that numbers just don't affect gradient at all, so they're not part of the differential. Now we want to show this is bigger than or equal to 2 for all values of x. Well, we know that x squared is greater than or equal to 0. So therefore 3x squared is greater than or equal to 0. And therefore 3x squared plus 2 is greater than or equal to 2. Just go through this point. X squared greater than or equal to 0 because all square numbers are positive. Now we're going to try and find y in terms of x, given that we know that 2, 4 lies on the line C. Well, we have dy by dx, so we're going to reverse this dy by dx. So we're going to reverse differentiate to try and see if we can find what y should be. So let's have a go at doing that. So let's just try and work out what y is. So normally we would times by the power and add 1 to the power, but now, sorry, take 1 off the power even. But in reversing that, we're going to take 1, add 1 on the power. So we get x to the 4, divide by the power, over 4. Add 1 to the power gives us x squared. Now if we divide by that power, we're going to lose this 2 here, because 2 divided by 2 gives you just 1. Let's add 1 to the power. This is effectively x to the naught here. We've effectively got 7x to the naught, so if we add 1 onto this power, we'll get 7x. And then we've got to add some kind of constant. Okay, so we want to find c. So let's put in 2 and 4 and see if we can find this c. So we know that y equals 4, so put that in. And we know the x equals 2, so let's put that in. So 2 to the 4 over 4, plus 2 squared minus 7 times 2, plus the constant. 2 to the 4, 16, divided by 4 is 4, plus 4 minus 14, plus c. Let's put that equal to 4. We can cancel out that with that. We can cancel out that with that to leave 10. So we can see that c equals 10. Therefore, y will equal x to the 4 over 4 plus x squared minus 7x plus 10. Right, now we're going to try and find the equation of the normal to c at p in the form ax plus by plus c equals 0. And it's going to be at p, so it's going to be at 2, 4. And we want to know what the gradient is at 2, 4. So we take dy by dx, which was x cubed, so cube the x, which is 2, this 2 here. So 2 cubed plus 2x, so 2 times 2, minus 7. 2 cubes 8, plus 4 is 12, minus 7 gives us 5. But we want the normal. This gives us the gradient of the tangent. So therefore, gradient of the normal equals minus 1/5. So if we use y minus y1 equals mx minus x1 as the form of the equation of a straight line, you get y minus, the point y1 is on the line, is 4, equals minus 1/5 x minus x1, which is 2. And if we simplify all of that, we will get 5y times by 5 minus 20 equals minus x plus 2. And we want to get it in ax plus by plus c equals 0, so let's get everything to the side. So we're going to get x added onto this side plus 5y minus 22 equals 0.